And now we come to a cycle. A cycle is a path that starts and finishes at the same vertex. So there are no repeated edges or vertices except the start and finish vertex, also known as a closed path. So for example, the cycle below can be written as B, C, A, B. So I'm starting at B, I'm going C, A, B. So I'm starting and finishing at the same point, but now I don't repeat any vertices, do I? So let's write down what our restrictions are here. So I've got 2 restrictions for a cycle. So my 2 restrictions for a cycle are no repeated vertices, if I can fit it in, vertices. And then you'd have to put in like little brackets here, except start, finish, because that will be, but we don't count that. And also no repeated edges. Repeated edges. And that's what it is. So remember, in contrast, our circuit up here could have repeated vertices. That was okay. So up here, repeated was okay. But now, take note of something. A circuit was a type of trail, which means it had no repeated edges, when a cycle is a path. And remember, our definition of a path, we come up here, our definition of a path was something with no repeated edges or vertices. So we can think of it as a cycle is a type of path, and that's why it has no repeated edges or vertices. When a circuit is a type of trail, so therefore it can't have any repeated edges, but it can have repeated vertices. All a bit much to get your head around, but it's not that bad. It's just, we'll take some time to let that sink into your brain. Hopefully that makes sense, and I'll see you in the next part.